All right, we're getting started here, working on my COFF deep dive series. In particular, I am working on generating an executable file from my own code. So I have this PEGen program going, and it builds, it runs, and when it runs, it generates a file, which I have loaded over here in my little hex viewer. So generated EXE is the one I'm generating. Mini EXE is the one I'm comparing it to. And we want to get to the point where I should be able to click on generated EXE and it doesn't say that it can't run on my PC. If we look, Mini just runs, right? Mini is fine. Generated is not. If we want to, we can go like this. We can look at Mini run here in 4Coder. We see we get exited with code 1. That's the same thing that generated should do, but instead it gets this. Cannot execute binary, exec format error. So there's an error still. My file's not good enough. And today we are going to be doing the task of getting this to run at all costs, which is going to be, the only way to do this, I think, is to be ruthless about it. Whoa, these aren't lined up, for one thing. Thought these did line up, but now they don't. Let me rebuild Mini real quick. I have maybe changed it since yesterday after an experiment. Yeah. Yes, reload Mini. There. Nope, still no match. Weird. This chunk here we don't know anything about. But it appears to have changed size. Wait, no, it hasn't. I just need to do this. Boom. There we go. So that and that. These don't match each other. I'm actually going to fix that first. So after... seven zeros. Yeah, so here we go. There's the 7 zeros. And then there's this block. Which looks like this. OX over, comma, over, boom. 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 OX over, comma, over. OX over, comma, over. OX over, comma, over. OX over, comma, new line. Repeat, 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 repeat. And then the last one is gonna frick things up, so do that one manually. 1, 2, 3, 4, 7, 8, 3, 4, 5, 6, 7. So that's 1, 2, 3 blocks of 8 by 8 calculator time. 8 times 8 is 64 times 3 blocks is 192 plus 8 times 8 times 192 plus 8 times 7 248. PE DOS header, size of PE DOS header. Just need to double check. 248 divided by 8 is 31. 8, 16, 24, 31. Okay, yeah. The baker says, it's really frustrating that Windows doesn't give you any information about what's wrong. Yeah, that's for sure. So when we run, just to fill in what they're saying for everyone else following, when we run my generated EXE, it just says there's an error. It doesn't give you any diagnostics. And that's really unfortunate. And the baker says, black box A/B testing is the only way I've found of progressing on my PE generator. For sure, you just gotta keep building them until you figure out which ones work and which ones don't. Sort of scientific method, you know? It's a science problem. You have a machine, you don't know how it works, but you can set up experiments and see what they result in and build a mental model from those experiments over time. It's the only option we have. Cool. Okay. So, let's see. So far, all of this and all of this should be an exact match. Are they? Wish I could diff them. Okay, cool. So F0 is where we have our first mismatch. Interesting. 1, 2, 3, 4. Generated EXE. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Interesting. Hold on, I think the mistake might be that I might have... Right, okay, so... The offset here is being derived from how big this is. But this should actually be a multiple of 16, not a multiple of 8, right? This much here... One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oh, there's the mistake. Okay, so it's 8 less than I thought. It is 240. Yes, reload it. Redo the diff for me. So our diff begins now at F0. That's the timestamp, so we're fine with those being different. Moving past the timestamp, the next thing that's different is they both, at line 100, they both say 0B02 and agree on that. But then this says major linker version, minor linker version, and mine says FFFF. That's fine. We like that difference. Size of code is 00C2, and over here it's 16 bytes. Okay. So the size of the text field in this one is OXC200. We're going to try recreate that exactly. sections.text, freeform section starts here, and it goes for C2 for so much code, so much code. So much code. Oh my gosh. How far? How far? Okay, not that far. There. C2 plus 400. Yep, that makes sense. We're going to copy that. We're going to copy, paste. Hold on. What is copy as? C array. Tell me about that. Brilliant. Okay. That's really nice. Well done. I'm impressed. There's our big ass text section. That's 8, 9, 10. So it's living at, okay. Section table dot text, virtual size 49,648. RV 4096. R put F off 49,668. 664. Why is this bigger? Oh, it must be 0 padded, and then we don't actually need the 0 padding. So this is saying 49,648. That's cutting out how much? And that's a difference of 16. So yeah, it's just like the file contains the alignment padding. We put that in the file size, but then we don't actually copy that for the virtual size. So it looks like this. Timestamps are different. Version numbers. This right here, why is this still different? Size of code 16. $49,664. So that's this version. $47.12. Zero 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 041. Right. 000040001. Okay. Okay, let's go back to the diff. Those are version numbers. Why is the size here different? Because we just now fixed it. We need to run it again. Bit by bit, make these match. Gotta be ruthless about it. Okay. This, what is that? Size of initialized data. 5,176. So here's a question. Is that one of the sections or is that multiple of them? So this one is R data, which has size of raw data. Yeah, okay. So if I take that plus that plus that plus that plus that. That doesn't give me the full size of raw data that they have here. Size of initialized data, 5,000. 50,000. I'm only getting 45,000 from all the parts I added together. There's 36,000 right here, plus 2,000 here plus 3,500 here. $512 here. $2,048 here. I'm missing 5,000 bytes of initialization data. Is it also adding in this? No, it couldn't be. That's huge. That's too big. Size of headers doesn't get us there. I wonder... Let me check what the docs say about this. Size of initialized data. The size of the initialized data section, or the sum of all such sections if there are multiple data sections. Yeah, you're saying that. But this says 45,000 is the sum of the data sections. And while this is saying 50,000. I'm missing about 4,500 bytes of whatever you're counting. Right, there's 56,000, 8,000, 34, yeah. Weird. Okay. So we're going to cheat. 5,176. Header total size of initted data equals 50,000, what was it? 50,176. Note, do not understand how this is summed yet. Okay. Size of 0 to data is 0. Just being ruthless about making these match. So all of this matches. Where's this mismatch? 140. Size of image. Right. So that lives in optional header. The size in bytes of the image, including all headers, as the image is loaded in memory. It must be a multiple of section alignment. Okay. So this number here is going to be the size of the loaded image, which is in this case, $4,096, 57,000, 94,000, 100,000, 106,000, 110,000. So we want this number here, 110,592 plus the virtual size, 1608. And then rounding up to a multiple of rounding up to a multiple of 4,096. This will become 8. What? You really do me like that? No, 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 no. That's ridiculous. Okay. 110592 plus 1608. Jeez, this thing is weird. Okay. We're going to take this amount. We're going to add in 4,095. So one less than 4,096. Then we're going to bit shift. 10 is 1,024, so 12. And then we're going to bit shift 12 that way. 114688. 114688. Okay, that makes sense. So that's how it's calculated. Section alignment, image size. 114688. Calc as largest v-adder. Yep, reload it. Look at this. All right, we got those matching. All of this is matching. 180. RVA. What do you What are you talking about? Okay, so this must be number of RVAs must be the directories count. Right, so right here we have data directory count. Then we have 16 of these data directories. And right now, we just put them all in as 0. We're going to have to start putting them in with some real info. VOFF equals size equals. So let's figure these out. The first one, 91936, size 40. Okay. Yeah, let's go. So actually the first one is 0. It's this one here. Let's just do these like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, one at a time. Okay. I was thinking about the handmade low-level approach versus trying to use libraries for everything the other day, and what you get out of it. What you get is control over quality. The price of that control can be steep. Yeah, I agree. I think there's another thing you can get out of it. Um, so yes, it's control over quality, but it's also control over innovation. It's control over the ability to rewrite the rules of the game. And that's what I'm working on. So it's not just that I want it to be good, because I think I could just grab LLVM or any of the existing handmade compiler backends, and it would be good. It would be good enough. I could work on quality from those angles. But what I'm actually looking for isn't just to have a quality code generation system, but it's to have one with features that don't exist yet in other systems. And so in order to get there, I need to deconstruct what's already available in a way that gives me the building blocks. I need to take what we have, atomize it, and then redo the chemistry to make something new. But that's my own personal flavor. That's why I do research, because I look for new things to build. All right, so looking at this now, the number of RVAs, the first one is 0. Here we go. So we have one that has 40 bytes, 91936. Actually, let's do it as hex. Copy as hex view, maybe? What is that? What is that? No, that doesn't do it. Copy as hex view. No. Alright, we'll just copy. Paste. 0, 1, 6, 7, 2. The size is 40 bytes, right? We said 40 bytes? Yep, okay. 0 for this one. Okay, so 0190. And the size is 3444. Yeah, that's awesome. Doing anything that people say can't or shouldn't be done. Well, sometimes people say something shouldn't be done for good reasons, but sometimes people are making that up just to be like, no, you shouldn't this isn't the way we do it. And, sometimes there's a good reason to, be a little less realistic. Imagine something with a little more magic than what we've done before and see what might happen. So, good luck. Sounds like a cool project. So, I think it would be easier if I did this way. Into the directories from here. So 0 to 0, 0. 1, we got it. 2, 0, 0. 3, we got it. 4, 0, 0. 5, okay. 0, 1, 2, 3, 4, 5. Base relocation table. Nice. Base relocation table has this size. And 1B 0, 0, 0. Glitchu asks, what's the hex editor? This is a hex editor called imhex. It's actually really cool. It was recommended to me on a stream a couple of streams ago. And it's free and open source, and it comes with built-in data patterns that like recognize lots of formats, including the one I am learning about called COFF. So it just like highlights the structures for me. It does stuff like diffing. I'm really liking it. Yeah. All right. Debug 84 bytes at location 15750. Zero, one, two. There we go. 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Load config table. Okay, makes sense. Load config table has a size of 320 and a location of 15610. $544. All right. Yes, reload the thing. Redo the parts there. So these ones are the ones we're tolerating. All of this now matches. So let's see. That all matches. Our data. Here we go. Our data, virtual size, RVA. Okay. Size of raw data. Okay. Okay. Gonna have to move these off of this file because they're slowing me down too much. Okay. And said we'll include Mr. Forth PE gen data.h. Our data equals C600. Okay, so C600 is the beginning of where I'm interested. Okay. And then C600 goes on until size of raw data. So putter to raw data is this. Okay. 5688 plus 36,864. Okay, close. Do it again in decimal. 5688 plus 36,864. Switch to hex. So we're starting from C6 and going until 156. Okay. Starting from C6 and we're going all the way to 156. Copy that. Well, copy as C array. C6. All right. Now, the virtual offset is going to be like this. That's the virtual size. The virtual offset is going to be like this. The file offset is going to be like this. And this will be the size of our data. Okay, so all of that matches. Okay. So now we're looking at the .data section, I believe. Yeah, this right here is .data. We can't quite see past the end here, which is unfortunate. And so now we want to make our data sections match. The data section That gives me an idea that I'd like to check. But let's start with let's look at .data. .data starts at 15600. It goes to 156. Okay, right after the R data. And it goes to there. One 15600. That's the starting point. F off size of data. Now the V off. Okay. And if I run that, yes, reload it. Yes, reload it. This takes a minute. Yes, reload it. Yes, reload it. Yes. Reload it. Okay. Don't know what that was all about. Maybe it needs to be clicked a bunch of times. Actually, maybe it needs to be spammed for it to work. That would be a first, but kind of seemed like it. Okay. So it looks like the new data section isn't actually being written with all the new properties still. Dot data, sec. Yeah, that's all in there. Plus 0, 1, 2, 3, 4, 5. Oh. Let's try closing this, running this again. Permission denied. What? Let's see if it's stuck running right now. No. P. I don't see it. Sometimes this is a little finicky. Yeah, there's no sign of PEGen running. Why can't you... Okay, you generated it. Permission denied. What does that mean? Why aren't you generating an EXE for me? Yeah, there's a PEGen right there. The system cannot execute the specified program. Okay, wow. Okay, let me think. So it's the Microsoft security system that is stopping it from running. I know it's not a virus, but look at that. It's like it's not even. Okay, so if I build, it generates PEGen EXE. If I try to run this, it's gonna be concerned that we have a virus. Run as administrator, yes. Boom, and then and then it deletes it. Okay. Is that because this looks too much like something that's generating a program? Yeah, now it's just blocking me on that too. Okay. What if I rename it? Maybe the security system is memorized a name, and I can just change the name of it to make it work. Maybe. That's a interesting comment. Thanks for the idea. Windows 10 exclude directory from Windows security. All right. Just because I don't know what I'm doing, this kind of feels like a let's do this. Let's do this without putting it on the stream. If I knew what I was doing and I could walk you through how to mess around with security stuff, I would. But if I'm doing something stupid, I'd like to put as little of that information into the world as possible, partly for myself and partly for everyone else. Okay. That was pretty easy. Thank you for the suggestion. So it's letting me build and run the PE generator again. And let me just make sure PE gen data. Looks like I have everything enabled again. Yeah, it's all here. Okay. So that makes me wonder if it started blocking me from running the generator. Did it start to think that the thing I was outputting was a valid executable? No, we're not that far yet. Okay. But I should be able to take generated EXE, drop it in right here. Yes. And then diff mini EXE with generated EXE side by side. These are the ones we're ignoring. And so data looks good now. And we can pick up from pdata. Yeah, someone on the chat is thanking me. I'm not entirely sure how to pronounce your name, Lee Kamichael, something like that. But yeah, I'm happy to put those conversations out. I get a lot out of them myself too. Lee Michael, I get it. Lee, comma Michael, makes sense. Makes sense. P data. Okay, so P data. Where do we have the disagreement here? Well, it's just going to be in the virtual size again. So let's go. We've got P data. Pointer to the raw data is going to be 16000. Okay. So if we go to 16000, and then we grab no, 90112 plus 3584 hex. Okay, 16E00. So we want to get the point where we find E, and we don't want to take it. Okay. Copy a C array. P data. P data section. P data. P data. Okay, this again, 16000. Very good. Dot P data. Okay, file offset OX16000. Size of P data. Virtual size 3444. Virtual offset 19000. Okay. Yeah, look, making UI systems from scratch is not easy. It really is months of work just to get all the basics up and running to the point where you can work with them, right? It's sort of like, it looks like it should be a day one thing. That reminds me, I gotta click on this until it works. This is like a idle game or something. I don't know. I don't know what the rule is on getting this thing to reload. But like, implementing a button, implementing a text field that, like, you know, a label like this box here, they're all trivial in theory, but there's a enormous problem with, like, you need to create so much UI that you're not just designing the implementation, but you're also designing the sort of language you are going to use to stick together pieces rapidly for the rest of your project. And developing a language rich enough and performant enough to keep up with you, that's tough. That's real design work. Okay. P data is all lining up. Now we're on to R data. The second R data. EXE16E00. That's going to go for 512 bytes. That's not much. To 17. Okay. That's really interesting. Designing your interface for how you construct software is a part of API design, and language. Languages provide the grammar, the as you put it, the API surface. There's a sort of geometry defined by the language of what's possible in an API, and the APIs then are your problem domain specific vocabulary, and using that, you're sort of, as a programmer, given the task of designing your own interface for constructing software. And what properties you want that interface to have is an interesting and important part of the design process. And what it sounds like you're saying is you wanted something where the actual visual layout of the text on the screen is related to the final layout that you get. You wanted a visual correspondence between what the interface of the code construction or software construction process looks like, and you wanted that to sort of map onto the artifact created by the code. And I think that's a really cool goal. I'm curious how you went about achieving that, because I don't know exactly that I can picture how arranging the code visually would do that, but that's really cool. Okay, so we have our data. We have the file size of our data. The f off of our data was OX16E00, if I remember correctly. $348. $1A000. Come on. There we go. Then redo the diff. All right, I'm going to take your code sample here. We're going to do a little detour. I know I said we have to be ruthless about getting this done today, but we're going to take a quick detour and see what this is like. Was it something like this before? What language is this? Is this C? This can't be C. C++, you can make C++ look like this. With no comma here? Okay, okay. If this is C++ and there's a comma there, then I got it. Style colon is a little funny looking. You can do this in C. Yeah, this isn't like... Oh, does this have an optional parameter? Is this like a new C++ optional parameter, kind of like named optional parameter? Is style the name of the parameter and bold is the value? Or is this supposed to be more like dot style equals bold or something like that? Gotcha. Gotcha. Cool. Neat. I see how you're doing it then. So to make a button that says press me in bold with the color blue, you're stacking the text on top of the rectangle. And to make a column of words that presumably space out vertically, you're doing this. Okay. Okay, here we go. Last one, global var u8 r data. Cool. Copy as a C array. Paste. There it is. This should be relock. Size of relock. F off. I think we said 17000. V size 1608. V off. What have you got here? 1B000. Nice. And dot relock 1700. Hey, hey. Hi, Ginger Bill. Hi, everybody. Looks like Primogen just rated the channel while I was locked in on finishing this up. We are trying to generate a PE file right now that actually runs, and we're getting really, really close. And I was saying at the beginning of the stream that I have to be ruthless today because there's so many unknown variables on this problem that if I'm not ruthless, I won't ever get it working. So I'm just really, really getting into it. The hex editor is called imhex. Someone recommended it to me a few streams ago, and it's really cool. It's free for one thing, and it comes with a bunch of built-in patterns that highlight for like different file formats that highlight what you're doing. It's got a lot of fancy stuff I haven't learned about too, like data analysis stuff. You can write your own pattern scripts. You can do these visual scripts to like process encrypted or compressed data through the hex editor. It's really, really fancy, and it's free and open source. Like, it's super cool. Do you know what that reload source thing is? Not sure where it comes from. So I'm not entirely sure what's causing it. The file I am trying to visualize in the hex editor here is the file I am generating, right? So I'm making generated.exe, and generated.exe just got changed because I ran my program again. And so I'm trying to reload it, but the program, like, I'm not sure if the file is locked or if it gets stuck, like, parsing for a while or something happens where I have to, like, sit here and spam this for a little bit to make it work. Might be a bug in imhex, might be some kind of nasty interaction between how I'm generating it and how it's getting loaded in. I don't really know. If I just ignore it, it wasn't doing anything. Like, I had to keep coming back and clicking earlier. Yeah, I could restart it if it takes forever. Usually this just takes a minute, and then I don't have to redo my layout, which is nice. I don't really know. There we go. See? It comes in. And then I have to tell it to do this again, so it'll actually update the diff. And now we're going to take a look. So we have on the left an executable that we know runs. Mini.exe. It doesn't show anything when I run it that way. If I want to, I can run it right here. /mini. Boom. And we can see it returns a 1. The goal is to get generated to run. And now I might be at the point where I have exact parity, where the two files are identical to each other. Almost. There's a couple little bytes that I'm ignoring at the very top. A timestamp and a version number on the linker. But for the most part, I'm copying these exactly. And so I want to scan through and see if there are any diffs remaining. There's some. What did we miss? (16E). I thought we put something there. Oh. Okay. 16000 R data. But I don't put the R data section down. Okay. R data. R data. 16E. Alright. Run the generator again, and we're back to this. Oh, that happened instantaneously that time. Well, thank you. Very kind. Okay, and now the only differences are these two. So there's like, it's gotta work now, right? There it is. Okay, so we did it. That was the end of me having to be ruthless just to make it work. I can now run the generated executable. So to summarize, this C file here outputs an executable file, and that file is called generated.exe, and that generated.exe actually runs like this. Okay? Okay, so now what I want to do is I want to see if I can minimize my file to get the bare minimum set of things that I actually need to actually make it run. Let's see. Let's see. For starters, I grabbed this giant text section earlier, and I actually wanted to see if I could shrink it down to just this one. So what if we took out... It's a lot of raw data sitting over here. What if we took out this one? So no more built-in text section. And let's just try to shrink our text section down. So quickie program dot text, size of quickie program, v off, f off. So that can all stay the same. Import table, exception table. Some of this might become invalidated by what I've just done. We'll see. Quickie program. We should also try to figure out... Okay, I had a theory about what that might be about. We should figure that out. Entry point is now going to be 4096. Let me keep the original that was working in place. Okay, so I still make a text section, but now instead of being all of this, it's just these 16 bytes. Those 16 bytes should do the same thing, in theory. I kind of want to set up a new binding on my project. Run gen, let's call it. So, yeah, we'll go run fly. We don't need these. All we're trying to do is run the generated EXE. Reload my project. Oh, this needs to be called run gen, load project. Build my generator, run my generator, run the generated program. Okay. Maybe I need to type build here. Okay. So, that confirms that I can't just swap out the text section and expect it to work. That's not that surprising. Because as soon as I did that, a bunch of things that were probably referencing some of the code that's in this text section probably went invalid. Okay, now it's running again. So, what are we going to do instead? Let's stare at the file. Oh, well, we might have to wait a sec. Okay, let's stare at the file and think of a clever way. What is something that is likely to free up some of those constraints? So we can't just cut out the text section. But let's see here. Here's my generated file. Before I cut out the text section here, maybe I should think about trying to cut out some of these. I have the data directories. I have the data directory. Here they are, data dirs. So import table. What if the import table wasn't there? That's my first question. What if there was no import table? Wait, let me do this the responsible way. No import table. Okay, that doesn't work either. what is in the import table? So something we can do is we can, well, what's the easiest way to do this? I guess I need more bindings. Run dump build slash PE dump build slash generated EXE. Run dump, load project. There we go. Let's actually have run dump go to a file called dump. And we'll say false on footer panel. Load the project. F4, here we go. Let me get caught up here. So you're trying to create a PE file that executes from a C file, and now you want to minimize it and keep the functionality? Yes, that's exactly right. Hello, and welcome to the project. So my big project here is to do a bunch of research and comprehend as much as I can about the executable formats that we use on Windows and Linux in order to make better tools for inspecting them, rearranging them, and even to dream about new things we could build at the native layer to make programming better for native programming. And in order to get there, I'm chipping away at understanding these formats. Now, I've written a dumper for it in previous streams. In the last couple streams, I'm trying to write code that would spit out an executable file that could actually run. And there's a lot of challenges to that because there's a lot of ways that it can be invalid, and there's not really a good validator that will tell me why it's invalid. So one of the projects I might end up liking to do is to make a validator like that. But in order to get there, I'm going to need to start with something that does work, which is what I've got now, and then figure out what the bare minimum starting point is, because that will give me some amount of constraints that I know I can test. And so I'm trying now to shrink this down to a more minimal working executable. And so the trick is to like try to find something I can remove that won't break the whole thing. And so far I haven't had any luck, but we're just getting started. So let me rebuild my generator, rerun the generator, and now rerun the dumper. And now we can see that the import table is in fact not empty. And so what's in the imports? Timestamp, first forwarder index, lookup table. So is it really just 40 bytes of an empty lookup table? Is that a necessary component for a working executable? Is that the point? Imhex, no. Where is, yeah, here we go. Reload this. Import table 91,936 1672.0. That doesn't look empty. My dumper might be wrong. 1672.0. We're talking about 8, 16, 32, 40 bytes. Really? Let's We're going to use our debugger on our dumper, targeting the generated executable file. And then we're going to look for the import table section and see what that parse looks like. Unable to debug process, unknown reason. Interesting. Okay. Unknown reason, huh? We don't have a P dumper still running infinitely, locking that up, do we? No, and I can rerun it successfully. Okay, so it does run. Probably the code is out of date. Let's rebuild the dumper real quick. And now see if it'll let me run. Weird. Okay, now it's working. Let me answer some questions. What's the terminal/text editor? This right here is 4Coder. I haven't tried any demo scene compressors. Dan Boxer, I wonder if any of the required components of the P are platform specific, like Windows 10, Windows 11, or UEFI. They totally could be. Getting a full handle on all of this could be really hard. I think... Yeah, I don't know that this is a short-term project, but I kind of want to find the minimal set of things that work. I think I would tend to expect that there's some subset of features that works more universally, and then there are some features which are only available in later platforms. But I don't know if there's going to be a lot of stuff where it's like I think Windows is set up so that an executable that can run on 10 should run on 11 unless you're specifically using deprecated features or something, right? So I don't think that there should be anything like that. Question. I assume the dimension misspell is intentional. What does it mean? Well, it is intentional in the sense that I've chosen intentionally to keep it. I have a problem. I'm not good at spelling, and I never have been. When I first came up with the username, I was like 11, and I wasn't sure if it was with an S or a T, but the website where I was making my username, the S was already taken. So I took the one with the T, and I didn't think much about it. And now it just sticks because I think it's funny that it's misspelled. It represents me and my skill set properly. Yeah, I noticed that. Thanks, Felpaffel. I did use remedy wrong a little bit. I always get confused between executable targets and project files and stuff. It was a little bit confusing. So I understand. Yeah, that's definitely what happened though. Okay, so we are actually stepping through the dumper. We want to see what happens when we parse imports, because something funny is happening. We're getting v off plus size less than or equal to yes. Size less than or equal to dir size, yes. Min, max. Here are the directories. If import dir does not equal 0. V off. Ooh, that's not right. Max count. Okay, we're going to come back and fix 455 first. PE dump. This should be the size, not the virtual offset. And we're going to need to rebuild the dumper. And let's try to run to that point again. Okay, 2 is the expected number here. So we grab that, we go boom. First forwarder index, timestamp, name, kernel 32 DLL, lookup stride 8. Max count, import range max minus import lookup table voff gives us a max count of 0. Sim count is 0, fill sims, sim count is 0, import table, lookup count. Okay, so we end up with kernel 32 DLL, sims, lookup count. And then we break. So if I'm understanding correctly, the thing called import table should have been queued onto this linked list. It comes with the name kernel 32 DLL and no lookups. And when we go to print it, what do we get? So it should be saying something about kernel 32 DLL, and then this should be empty. Okay. But somehow that's coming out like that. Is it a problem with my %s? Seems like that's what it has to be. That and that came out correct. Name. Oh, name.size says 0. Why does that say 0? Let's go back up and look at this again. Right here, something bad happened. Name voff is 92848. 91. Oh, these aren't. Okay, so import range max is too tight of a bound. Let's go back and look at this. So we're looking at the import symbols here. Something's off with how I interpreted import symbols. The address of an ASCII string that contains the name of the DL. This address is relative to the image base. Right. Okay, so it just doesn't say anything about the restrictions. Let's just open up that range then. Line 469 in the dumper. We'll just say loaded data.size, right? It could go as far as to the end of the file. So we rebuild the dumper, rerun it, and now our imports looks like this. So if I'm understanding correctly, if I go to the import table, oh, this is in gen now. Build fly gen if I do this, import, then I just have no imports. And if I try to run it, it's like, it is unable to start this correctly. No good. Okay, now if I do this, rerun the generator, build the generator, run the generator, run the program, it works, dump it, and the difference is that it needs this. So I'm gonna guess that we need to tell it to import kernel 32 DLL even if we don't have any symbols to look up for it. Let's start taking notes. Okay, there's one. Import table. Okay, exception table. Again, I'm curious, does the program survive me cutting that out? That works. I can just cut that out. That's cool. Okay. Base relocation table. Interestingly, this is probably something we can cut out if we mark the flags a little different. I think if we took out dynamic base here, then it could work. Let me see. So I bet this will bust. Right. But what if I do this? Then it works. Okay. So that's if... Wait, yeah, take these back for a minute. So the requirement here is if PEDLL flag dynamic base is set, then base relocations must be provided. Okay. And let's cut those out for now. Boom. Okay. Generate, run. We are cutting stuff out now, which means the file isn't any smaller because all I've done is removed pointers to data. But if I remove enough pointers to data, the next step is I might be able to go and actually rearrange and shrink down some of the data sections I have to generate. Next up, we have debug. And I believe I should be able to just cut that without having to talk about anything else. Yep. Load config table. Okay, this one's interesting. Let's look at the dump real quick and see if there's anything interesting at all in the load config. So yeah, there's a little bit of stuff here. These are pointers into the text section, I think. Although this is not the text section, but these are, I believe, within the range of the text section. This is a little too big. This is like exception data or something. We have a flag here, so it's not empty. it's not empty. The question is, can I get away with shrinking it? Let's redo the dump here because we have exceptions are turned off, base relocations were turned off, debug was turned off, load config table. Let's just start with the direct test. Does it survive me removing that? Yeah, it does. Okay. So we can take that out. IAT. Now I think this is one that I never actually figured out what exactly it's doing. So we're finding out. Okay, so that is okay. All right, so that minimized out a lot of stuff. I think what we need to do next is go back through and figure out where these pointers were pointing into the file and what sections we can shrink because of that. Glosum, so is the goal making a minimum viable executable file? Yeah, basically. I have a generator that is generating out executable files, and I want to have a good handle on what is and isn't allowed. So I'm looking to learn how, Windows doesn't come with a verifier. If I give it an executable file that isn't quite valid, it won't tell me why it's invalid. So really what I'm exploring is what are the requirements you need to know to make an EXE valid? And can I find like a nice, I'm not necessarily going to find every rule ever, but I'm going to find a space in which everything that I care about is achievable, right? So that's like writing regular code, exception handling, debug, like all the basic core stuff that I need. I want to be able to master how to generate that stuff and when it is or isn't valid, right? And so I'm chipping away at it to find those limits so that I can, yes, make it minimal, but also learn where the limits are. Yeah, the thing is when you run the program, if it's invalid, the only feedback you get is not executable format error. It doesn't tell you specifically anything. So you have to trial and error to learn a lot of this. Okay, so I've pulled out all the data directories. Let me check what time I'm at here. I'm almost at 2 hours of work. I feel like there's a lot of momentum today on this project. So I'd probably like to go a little longer, but I do need to take a short break. So I'm going to take 5 minutes or less, and then I'll be back to wrap up with maybe trying to chip away at some of these data sections and see if we can remove any. But I need a quick stand up and stretch and rest my eyes, kind of break. So I will be back shortly. While I'm away, you may consider checking out the Mr. Fourth Lab website. All right, 1 minute. All right. So these are pointing in all kinds of places. This one here, E000, matches our data, and the size of this is 36. So our data contains a lot of stuff. Our data contains a lot of stuff. I wonder if there are other things pointing into it. I also want to go and reread what IAT does, because that was, like I said, one that I didn't actually fully dive into before, but I don't think I had like good info on it coming up either. Import address table. The structure and content of the import address table are identical to those of the import lookup table until the file is bound. Okay. So this is supposed to be the same as the import table? Paul Paulson says, in my PE generation, the only data directories that I set are import directory, debug directory, and import address table. All others are set to 0, but I don't know much about it. I mostly imitated the reference EXE that was generated by assembler. Yeah, makes sense. The debug directory is optional. It's necessary if you want to be able to attach debug information into your EXE. So like if you want to be able to run your program in a debugger, that's what the debug directory is for. Yeah, import directory seemed to be necessary. It looked like import address table actually wasn't necessary. Like I zeroed it out and it's still running. And it also doesn't do what it says it's supposed to do. It says it's supposed to match the import table, but it's actually like different from the import table. So I'm curious if I look at the data here for our data. Let's just track something down here. So this is the virtual offset 16720. The hard thing is virtual offsets are encoded in the data directories, and those aren't file offsets. So I need to look at the virtual offsets for all the sections. And map those back. Okay, V off 1672. So this must be pointing into our data as well, because the next section, okay. Okay, we can calculate this. Why do I have two of these? Let's just use the one I've got. Thank you. Hex editor. 16720 minus E000 plus C600 14D20. Okay. If I go to my hex editor, yeah, reload it. We're looking for 14D20. So here we go. Here's those 40 bytes that make up the import table. And compare that to import address table E000, which is the very beginning, so C600. Yeah, this is just totally different. So the structure and content of the import address table are identical to those of the import lookup table. Okay, I think I didn't fully understand this before, but some of it's clicking. So we have these import directories, which contain things like an import lookup table, an import address table, a timestamp, a forwarder chain, and a name. Let me go to remedy. Look at that spot where it got parsed. And now let me look at import ders. Import dir, yeah. Import lookup table voff. Import address table voff. Okay, so we do succeed at getting a timestamp and a name. Look at the lookup stride. Import table voff. Loaded data attribute. Lookup table. Lookup table voff. Import range max. Max count. This must be garbage. 91976. 91976. Import range max must not contain these. That's what I'm starting to think. What if max count just happened to be a 1 instead of a 0? Then we look at the putter we've got. And that's not pointing to a null. So J goes up by 1, putter goes up by 1. Now we're done. Sim count becomes 1. Yeah. Okay. So Stone Monkey Mark is mentioning that on my website, the light mode and in light mode, the code isn't readable. I hadn't noticed that. I will take a look at that. Thanks for the heads up. No, I haven't. I haven't used the locals from Visual Studio. Okay, so the imports are being parsed wrong in the dumper, we're learning, because I mistakenly thought that the import range max would contain the import lookup tables, but it doesn't. So instead, what I need to do is I need to set this based on loaded data.size. That'll give me a safe max. So let me go build the dumper again. And then let's dump. And look at that. We're actually importing some stuff. Good to know. Okay, so this is just a bunch of necessary imports for kernel 32 DLL. So if our imports table is not empty, then that explains why the IAT is a little bigger than we thought. It looks like there's, in addition to the 40 that it took to get here, there's 131, 198. $67. So how big were each of these? 32 bits, so times 4. Okay, do it again, this time in decimal. 198 minus 131 times 4. Oh, no, it's gotta be times 8. $198, $131 times 8, 536. I'm missing 1 somehow. There's one more. I guess there's a null at the end, right? So there's a null at the end. Okay, so this IAT here is just this one here. Okay, and finally, if I look at my breakpoints, do I have one? Don't need this. Right here. Pop into here. We get, there are 2 directories. We take the first directory. We use its import table voff to get started. We don't know how many to expect yet. We start counting them. Ultimately, we get this many, 67 of them. But the point is this number here. Import dir import lookup table v off x 16748. That's in the v off space. So now we go over to our sections. That's going to go into our data, hex mode, paste 16748 minus E000 plus C600 14D48 14D48. Right, so there's the beginning of yeah. So this 40 bytes here is our directory table. You can see the second one here. So there's one. The next one is null. That's the end of the table. Then here's the lookup. What's the second name? There are two names here. The import lookup table, right? And that's what this is pointing to. So it's outside of the range from the data directory, but it's this thing, which ends on that null. And then later we find IAT, which is exactly at E000, which is C600. And so that's way up here. Let's see, we want to copy this, drop it off in the scratch. Try again. Copy that. Jump back up to E000. It's around here. CDE000. No, sorry. C600. Yeah, and that's this one until the null. Copy. Hold on, let me do a safety. Copy, paste. Yeah, that's what I thought. Copy, paste. And now we're just checking that these look identical all the way through. I think they do. I think they will. Yep. That's pretty convincing. Yeah, okay. Okay, so if those are identical, then we're understanding what's happening. I don't think... It doesn't make a lot of sense that it's allowing me to eliminate the IAT if it needs that for linking, but I guess it's also finding those through the import directory, because the import table itself then points to the lookup table and the import address table, right? So what purpose this serves, I'm unsure of. But what we do know is this is just a block of data, basically. That's why the size is 544. It doesn't have the header. It's just the lookup table part. Okay. So having understood all that, the next question is, what can we do? We can't wipe out the import table. That'll break stuff. But could we get away with rewriting it? I kind of feel like we could. Let's just try something a little ambitious here. Here's the original R data. We're going to make a copy of it. We're going to simplify. Okay. Give me a minute while I work this out. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 bytes per line. We are going to want... How many is this? Well, it was 544 bytes, right? Divided by 16. 34 lines. So we want 34 lines. Let's see here. Let's start like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 30. 1, 2, 3, 4. The last one here is null. The rest are the ordinals that we need. Now, the next piece, this is all other stuff from other systems. The next piece we know we want connects in from the import table. Boom. Okay. Dump. No. Yeah, dump, import. No. I want to look at the dump. Import table. 16720. We subtract. Right. Here we go. 16720 minus E000 plus C600 14D20. Right, so we're looking for this combo here. Interesting, and this is where it gets funky, because these look like function names, don't they? Don't they look like function names? And so there's some chance that these aren't just ordinals, that they're pointing at these, but I don't know. Hint. Where do the hints come from? Remind me where the hints come from. Pe.h, hint. Import directory table. If high bit, then ordinal equals low bit 16. Else, hint v off equals low bits 31. Hint is a U16 and a null terminated C string. And so these things here are giving eight bytes at a time. Ordinal flag is off. Okay, so the dumper isn't doing the right thing still. At this point right here, It gets hint v off from that. It grabs a name, create performance counter, and puts it in the sim. Okay, so if that's true, then why didn't we see that when it dumped? There should be a name that size is 0. Okay, so the capped C string thing must be the problem. Import range. Yep, there it is. Line number 526 in the dumper. There we go. Got it. Got it. So I want to go check. Up here at C6. No, it doesn't contain the names again. So in order for these to get resolved into strings, that right there is the pointer. It's got a 0 over here. Yeah, that's the pointer to the C string living over there. Okay. Okay, I get it. Okay. So these are file relative pointers, and if I go and delete a bunch of stuff here, they're going to point at the wrong thing. I'm going to have to figure out how much I'm deleting and subtract the right amount for this to work. What am I thinking? What am I thinking? I don't know exactly where it starts, but somewhere 14D20. If I see 8720, okay, so let's look at that. 8720 is how far into the RData section I have to go to find the lookup directory stuff. Divide that by 16 to find out how many lines it is. Oh wait, and I did that in hex. 8720, switch to the decimal, divide by 16. So it's 2,000 lines down from the beginning. So here's 10, 20, 34. So we've already done 34. We got to go 2,000 lines, 2,128 lines more. So I'm at line 3,152. 5280. Let's see if that works. There we go. Okay. Now this part here, I believe we are looking at 16, 32, 1, 2, 3, 4, 5, 6, 7, 8 bytes. And then this is the same thing again. So just like we did at the top, we want to pull out 34 lines, except this time the 34 line starts right here. So one, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Right? And again, there's 8 zeros here to end it. 4, 8. This is something else, right? Okay. So the ambition here is to delete all of this and leave behind just these things. Let's try it. So we're talking about 3152 to 5280. 2,128 times 16. That right there, 34. Okay. Save that. OX8500. Delete that amount. Boom. Now each of these that looks like a pointer needs to get rewritten . This is hard. This is hard. Okay. Got it. Okay, I see what we're doing. Calculator, hex 16968 minus 8500 E468. 16982 minus 8500 E482. Jeez, this is going to take a long time. I'm not 100% down for doing it this way. I'm trying to think if there's another way I could do this. So I think the experiment I want to run is valid. I'm just going to need to take a simpler approach, something that'll be a little easier to achieve. So let's start again from the original R data. And instead of changing the size of the R data, I'm going to zero out everything except the part that I think is actually relevant and see if that is good enough. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Great. Now, from here, we jump ahead a certain number of lines. Looking at the dump. Let's see. The dump is saying the import starts at 16720. And of course, the IAT started at E000. 8720 is the hex version. Divide 16 from that. We're looking at 2,162 lines plus 3151 give us 5313. This line should be the last one here. There should be 16. $32. No, that's not quite right. What did I miss? Hex. 16720 is the V off where this starts. E000 is the V off where that starts. We've already taken 34 lines out of the equation. Plus 3151, 5310. This just doesn't look right. I'm looking for OX 6, 8. OX 6, 8, comma, OX 6, 9, comma, space, 6, 9, comma, space, OX, 1, comma, space, OX, 0. Here it is. There. There, one there. Okay, so that's 1632. 40 bytes. And now we want to do lines again. So 1, 2, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Now at the last, I missed it somehow. This is definitely the right starting point. this is the right table structure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's this right here. There we go. So if I were to rearrange this, I would get something like go back. Done. Off by 1 right there. Very good. And then sticking it all back together. Boom, 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 boom. Boom, 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 boom. Boom, 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 boom. Do. Very good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 4 more. Okay, so there we go. That's the section that we want to preserve. This is everything that it takes to do the import symbols. If everything else here became zeros, would that be okay? It would be like this. OX00. GamerX asks, what stretches do you do, and how do your eyes chill on a break? I usually get up and walk around and like, I don't know what you'd call it, but like, you know, twist my spine. And if my back is feeling stiff, I'll also like lean against a wall and stretch out my back. Sometimes it's my lower back, but mostly it's like blinking and looking out the window, kind of just pacing around for a few minutes, making sure my water is full. I probably should do more specific stuff, like, you know, I could actually imagine once an hour stopping to do 5-minute, 10-minute yoga would be much better for my low back if I just like, I forget what the one is called where you put your shoulder underneath. That one does a lot of good for me when I think of it. I don't know. I'm not very structured about it. It's mostly just getting up and walking around and shaking everything out. Take a while. We literally have like 2,000 lines of this to do. All right. Hopefully, I'll just do this section and see if it works or not, and we'll have to call it there because I'm getting close to 3 hours now, and I'm definitely hitting my fatigue limit. So this will be a cool final experiment for today. At least the cool part is I did get the new executable working. Minimizing it is going to be an ongoing task, it feels like, for a while. So far, I'm just hacking at the data structure, like the raw bytes that I originally got from brute force cloning the example. But at some point, I should start creating like a structured constructor, right? I could, instead of having to rearrange all these bytes manually, I could make a thing that would lay out the lookup tables that I'm attempting to rearrange and set their pointers up correctly. And I could do that in such a way that I could test that my constructor was working, even if I did it before I was ready to minimize fully, right? And so that could be a useful way to make progress, and it might help it be easier to test out minimization procedures rather than trying to do it by hex hacking like I'm doing today. So I'm thinking that might be the next step, is at the end of today's experiment here, is to try to make a structured constructor for lookup table data. But I can't go past 3 hours because I got other stuff I have to do today that involves not being at the computer. Almost to 5,000 now. 4,800. I'm looking at that row number at the top of the screen in case anyone doesn't know what I'm doing. I'm zeroing out everything in this block. And the block ends at around 5,000, a couple hundred or something. 49. This is slow. This is so slow. $52. Somewhere in the 52 or 53 range, I believe we get a gap that'll come up and tell us where the end is. Here it is. Here it is. Cool. Now, how much is left? Only a little bit more. Let's just go for it. Wait, these are the strings, right? I haven't sectioned off the string part yet, so let's actually leave all this. This is just string data that I need. Okay. Because this is the end of the lookup table, and the lookup table has pointers into string data. Yeah. Cool. We'll leave it at that. run the generator, dump. Imports still look perfect. Does it run? It runs. Okay, that's awesome. The reason that's so cool is that means that anything that's pointing at our data besides the import table and all the stuff the import table discovers, that can all get wiped out. So once I do a structured constructor for the import table and plop that out, then I can just generate my own R data section. I don't have to use the copy from the original mini program. So that's a good conclusion point for today. If you enjoyed following along with this and you'd like to see more of the work I do, you can go over to mrforth.com. You can check out all kinds of stuff. The membership program is really cool. You get bonuses. You can see things like my weekly devlogs. You can see things like, if you become a member, the indexed video library. So all my YouTube videos are indexed there, or they will be soon. We're working on the index still. And so you can get access to source like the code I wrote today before it becomes open source. Some of the code might not ever become open source. So that's a good way to check it out and learn from it if you'd like. There's a lot of other perks. Videos come out early for supporters and so on. And you can also check out my blog where you can see projects I've worked on, software I've done before, my podcast, a bunch of cool stuff over on mrforth.com. So if you choose to support, that's very much appreciated. That's how I keep this whole project going. All of the things I do on Twitch and on YouTube, I'm counting on people like you who are watching to decide that you can pitch in a little bit to keep this sort of thing going. And with that, I will see you all around the internet. Bye-bye.